Hello everyone. Myself Gaurav Kumar Vani, Assistant Professor Agriculture Economics at JNK Jabalpur. Today we are going to talk about supply function of a firm in perfectly competitive market structure. So beginning with a short run. So in the short run market period, the variable resources are also there as well as fixed resources are there. So we can increase production by using more of variable resources, but up to certain limit. Uh, Here on the x-axis we plot the quantity, on the y-axis we plot the cost. So with variable resources we have average variable cost, and then we have marginal cost. So this hockey shaped curve is marginal cost curve. So marginal cost is the cost of producing an additional unit of quantity. Average variable cost is the variable cost per unit of output. So average variable cost is on an average how much we need to spend to uh, spend on variable resources per unit of production, and this marginal cost curve intersects the average variable cost at its minimum. So let there be P0 price on this cost axis. So correspondingly we have Q0 quantity of output that is produced, and this P0 is now called as reserve price. P0 is equal to the minimum of AVC. So this is the called as shutdown point, closing point, because if the producer is not able to recover the minimum average variable cost, which is he should really get, then he will close the plant and would be happy suffering fixed cost. So if he close the plant, then he need not incur any variable cost. He will be incurring only fixed cost. So that is like depreciation, salary of a fixed employee. If electricity is also fixed charges are there for the unit, then those electricity charges are also fixed cost. So all these he has to pay. So reservation price or reserve price is the price below which the supplier will not produce anything, and he will not supply any quantity. So this is must that a producer should get in order to have a positive supply quantities. Now, as the price increases, the quantity supplied also increases. Quantity produced is also increases. Here we are assuming that whatever is produced is also sold in the market. So the relevant curve here to determine the supply is marginal cost curve. Which portion of marginal cost curve? So here we have indicated that by the red color, and this red color portion is the supply curve of a firm in short run in a perfectly competitive market structure. So now coming to definition. So portion of marginal cost curve above minimum of average variable cost is the relevant supply curve of a firm in a perfectly competitive market structure for the output, not for the input. A unique supply curve exists only in a perfectly competitive market structure. The supply curve starts from minimum of average variable cost. The reason is already stated by me. Now coming to mathematical version. So let pi denote the profit, then it is denoted as difference between total revenue and total cost. So pi is equals to TR minus TC. Now assume that both TR and TC to be function of quantity of output. So TR is equals to, let revenue function is denoted by R. So RQ. So revenue function so is there. So revenue is a function of quantity Q that is produced, output quantity, and total cost is equals to CQ. So C is denoting the cost function. So C is function of Q. So pi is equals to RQ minus CQ. For profit maximization, marginal profit must be equal to 0. That is, the additional profit generated at the optimum must be 0. So d pi by dq equal to drq by dq minus dcq by dq, which is equal to r dash q minus c dash q. So here the first order difference of rq with respect to q is denoted by r dash q, and the first order differentiation of cq with respect to q is denoted by c dash q. Here we are not going in the specific functional form, that we will see in the example. So right now we must understand that the R dash Q is the slope of the total revenue curve with respect to the quantity, and C dash Q is the slope of total cost curve with respect to the quantity of output. For profit maximization, so this d pi by dq is equated equal to 0 because marginal profit must be equal to 0. So d pi by dq is nothing but marginal profit. Therefore, r dash q is equal to c dash q. So what is the physical meaning other than a mathematical meaning? So the r dash q is nothing but marginal revenue and c dash q is nothing but marginal cost. So marginal revenue is equal to marginal cost is the first order condition or so-called necessary condition for profit maximization. In perfectly competitive market structure, we know that price is equal to average revenue is equal to marginal revenue. All three are equal. So we can say the marginal revenue curve, average revenue curve, it's just a horizontal straight line. So price is equal to marginal cost can also be the first order condition for perfectly competitive market structure. But in other kind of market structure like monopoly, monopolistic, oligopoly, we'll stick to marginal revenue is equal to marginal cost. Only in case of perfect competition, we can say price is equal to marginal cost. But necessary condition, is not always holding good for profit maximization, because we know that when the slope of a function is equal to 0, then there can be either maximization or minimization of the value of the function. So we are not sure by equating marginal profit equal to 0 whether we will achieve profit maximization or profit minimization. So therefore sufficiency condition or second order condition is required. So now going ahead, so second order condition is that slope of marginal profit must be declining. So slope of marginal profit is obtained by further differentiating the marginal profit. So d of d pi by dq by dq. So we can write this as d square pi by dq square. So that can further be elaborated. So we can again substitute the expression for d pi by dq. So we get d of r dash q by dq minus dc dash q by dq, which must be less than 0. So further if we see this, then we can see this, the slope of marginal revenue must be less than slope of marginal cost. Now, coming further, in perfectly competitive market structure, marginal revenue slope is equal to 0 because the marginal revenue is just plotted as a horizontal straight line. So obvious it is that slope is 0. And now in a strictly convex average cost function, which we have already seen in the graph which was discussed before, so we assume that if the shape is strictly convex, then the marginal cost would always be increasing, because the if shape is really convex towards the x-axis, then obvious it is that average variable cost would be increasing after achieving a minimum value. Since average variable cost is increasing, so obvious it is marginal cost is always increasing. Thus, for second order condition in perfectly competitive market structure, the slope of marginal revenue is always zero, is always less than positive slope of the marginal cost. So these second order as well as first order conditions are satisfied if we have this kind of cost and revenue structure in a perfectly competitive market structure. Now, how to derive a supply function from a cost function? Although there are two approaches, one is cost function approach and profit function approach. So right now we are going to discuss this cost function approach for deriving a supply function. This is the basic approach. So initially we have to obtain a cost function that you may do by estimating cost function through regression or non-parametric, whatever. Then derive marginal cost function by taking first order difference of the cost function. Then equate marginal cost to marginal revenue. In case of perfect competition, to price also you can equate, because both are same thing, marginal revenue and price. Then solve for the quantity of output in terms of price. So this will give you a generalized supply function, but which will be valid for all prices, but that's not the reality. Then you need to find ABC function. So how do you find ABC function? From the cost function, you have to deduct the fixed cost, and whatever you get, you have to divide by the quantity of output. Then find the level of output at which the ABC function has the minimum value, because the relevant supply curve starts from minimum of ABC. Then substitute the output quantity into expression of ABC function to find the reserve price. Then define the output supply function along with the reserve price. So if you do not state reserve price, then everybody will think that the supply curve start from origin, but actually supply curve starts from the reserve price, not from the origin. From origin means the price is zero, but that's not the reality. At zero price, nobody will start a supply, positive level of supply. So now we take an example. So first step is obtaining a cost function. So let C be the cost of the firm measured in thousands of rupees. So cost is function of output, as we have already seen. On y-axis cost was plotted and on x-axis quantity of output was plotted. So C is equals to 0.1 uh, q to the power 3 minus 2q square plus 15q plus 10. So this is a cubic cost function. Uh, we have purposefully chosen this to illustrate this exam case. Here, if you put q is equals to 0, then obvious it is that c is equals to 10. Thus, fixed cost is rupees 10,000. Step 2, derive marginal cost function. So differentiate the total cost function with respect to output. So dc by dq equal to d O by dq of 0.1 q to the power 3 minus 2q square plus 15q plus 10. Now individually we will take up each of these. So here we are applying d by dq to each component. Then going further, I will first discuss how to do differentiation. So logically, if k is any constant which is associated with any variable x, then during the differentiation k will be taken out if it is associated with any variable. Then if you have to differentiate variable x with respect x to the power n with respect to x, then the differentiation of x to the power n with respect to x is nx to the power n minus 1. So here we have done the same thing. By the first rule, we have taken out whatever numbers were associated with q or any power of q, and in the next step you see here q to the power 3 upon differentiation by the rule nx to the power n minus 1. So we are writing 3 q to the power 3 minus 1 minus 2 into q square is now differentiated as 2 times q to the power 2 minus 1 plus dq by dq, 15 times dq by dq is there, so that is cancelling out each other. And then there is differentiation of 10, so differentiation of any constant, for matter any number you take, how big or small, it is always 0. Going further, once you solve further, so whatever dc by dq is there expression, so this is the expression for marginal cost. Now next step, step 3, equate marginal cost to marginal revenue or price. So marginal cost is equals to whatever was there, 0.3 q square minus 4q plus 15 equated with the price p, price of the output. Then step 4, solve for the quantity of output in terms of price. So now we see it's a quadratic equation. P is assumed to be constant in perfectly competitive market structure. So 15 minus P is something constant for us. And we have to solve the Q in terms of P. I know that many of the students know how to solve quadratic equation using Sridharacharya's formula. And they must be knowing these minus b plus minus under root of b square minus 4ac divided by 2a. So this way you can solve this, and the now you have an expression for q. So now going further to next step, step 5, find the avc function by deducting fixed cost from cost function and divide it by quantity. So this is our cost function, and we have already discussed what is fixed cost. So it is rupees 10,000. So c is equals to 10, is the uh, 10 is the amount of fixed cost here. So variable cost is equals to c minus 10, because total cost is equals to variable cost plus fixed cost. Total cost is equals to variable cost plus fixed cost. So that we have done, we have got variable cost. Now divide variable cost by the quantity q. So you get the expression for average variable cost. Now going ahead from these, now next step is find level of output at which ABC function has the minimum value. So this is what we had from the previous slide. Now to find the minimum value, first find the first order derivative of ABC with respect to Q, because whenever you have to find maximum or minimum of any function, you have to first take the first order derivative with respect to relevant variable or argument of the function, which in this case is q. So dAVC by dq is equals to d by dx of this AVC expression. So we are applying d by dx to each component here because it is linear, uh, linear in parameter. So we are doing it, and you know the rules of differentiation. So going further, so finally we have 0.2q minus 2. Now going further, whenever you find first order derivative, equate it with 0, and then you know 0.2q minus 2 is equated to 0. So 0.2q is equals to 2. So q is equals to now 10. I leave the second order conditions for you to do it, but even if you do, you will get negative, positive answer, which will be 0.2. So whenever the second order derivative is positive, it indicates that the function will attain the minimum value. So if you do d square AVC by dq square, the answer will be 0.2, which is positive, greater than 0. So it is strictly convex to the axis, and it has a specified minimum. Now step 7, substitute the output quantity into expression of ABC function to find the reserve price. So you already know Q is equals to 10. This is the ABC function. Now you put value, solve it further, and you find the value is 5. Okay, so 5 means what? Since all the costs are in thousands of rupees, so the minimum uh, price at which the producer will be ready to produce and supply is rupees 5,000. So the reserve price here is rupees 5,000. Step 8, define the output supply function along with the reserve price. So we have to say that quantity supplied or supply is equals to 4 plus minus under root of 1.2 p minus 2 divided by zero point 0.6. If price is greater than equal to rupees 5,000, else quantity supplied is 0, because below 5,000 the producer will not be ready to supply or produce any quantity, so the quantity supplied is 0. So this is one approach, the cost approach. Now we are moving to profit function approach to find or derive the supply curve. So let pi denote the profit, which we have already done, and as a difference between TR and TC. Now TR, that is total revenue, is equals to price multiplied by quantity. So price is denoted by P, quantity by Q. Now Q is again made function of the variable input as well as fixed input, because we are in talking about short run. So in short run, the variable input, only one input you have assumed, X, and one fixed input Z. You can assume more also, no problem. But now each X, in this case only one X is there. So each X is now a function of the price of output, the price of the input X, and the fixed factor Z. So total cost now we assume as W times X. So because W is the price of input X multiplied by quantity of input X. Q, so further can be defined because you can substitute X by this G, correct? So Q is again defined, so in terms of arguments of X. So now Q is function of P, W and Z. So total revenue can be written as P times function of P, W and Z. Total cost upon substitution of X by its function, we can write total cost is equals to W times G into PWZ. You may be asking one question, what about price of Z? So here we are not assuming any price for Z, but even if you assume, there are no problems. So X is variable input and Z is fixed input to production of output Q. P is the price of output, W is the cost of input X or price of input X per unit. So now we can write pi in terms of our TR and TC elaborated. So we can say that now profit is a function of P, W and Z. So profit depends upon price of output P, the price of input X, W, and the quantity of fixed factor Z. Also it is interesting that price of Z will not matter much because Z is fixed, so when we cannot vary its quantity or we cannot even work upon its price, so the relevancy of price of Z is immaterial, and also we are assuming perfectly competitive market for both input as well as output. So both P and W are fixed. Z is also fixed by assumption. So going further, under mild regularity condition, correspondence between production function and profit function is there. That means if profit function is of Cobb-Douglas specification, the production function will also be Cobb-Douglas specification. We'll see the proof also for the what I am saying. For a function to be admissible as profit function, whichever specification you take, it must have non-negative quantities It must not admit negative quantities, monotonically increasing in prices of output and monotonically decreasing or non-increasing in prices of input. That means if prices increase, price of output or output increases, then the function should always increase, because as prices of output will increase, keeping a price of input constant, the profit will swell, of course. So there shouldn't be any decrease. Okay. And then when the price of input alone increases, then the profit must decrease. It should never increase. Then convex in price of output. Yes, obvious it is. When price of input will increase, if you plot the profit on one side and the price on the x-axis, then you will find that the curve will have convex shape, convex to x-axis. Homogeneous of degree 1 in all prices. So if you multiply all prices by a factor lambda, which is feasible, or upon multiplication all the prices remain feasible, then the resultant profit will be lambda times, because we are assuming homogeneous of degree 1, so lambda's power will be 1. If production function displays constant returns to scale, then homogeneous of degree 1 in all fixed factors. So if you multiply z by lambda, then your output should also be lambda times, so obviously profit will be lambda times. Now, going further, the profit function due to Hotling's lemma has two interesting properties. It's a derivative with respect to price of product is equal to the supply function of that product. So this is very interesting, and this is the property upon which we are focusing. So if you partially differentiate the profit function with respect to price of the output, then you will get the output supply function. Not exactly production function, but output supply function. And if you differentiate, if you take partial derivative with respect to the price of an input, that is now in this case W, then you will receive negative of the demand of that input. So if you do so, then you will receive minus G, which is function of P, W and Z, which is equal to minus X. So we'll see the example. Let there be a Cobb-Douglas profit function. So ln pi is equals to A plus beta 1 ln P plus alpha 1 ln W1 plus alpha 2 ln W2 plus gamma 1 ln Z. So everything, all variables are in log term because we are assuming a Cobb-Douglas profit function. Now to derive supply function, obtain partial derivative of profit function with respect to log of price. We are doing it, partial derivative. Now you may again question why every time I am taking partial derivative, because if there are more than one argument of the function, then if you want to differentiate with only one variable by keeping others constant, then total differential is not the relevant differential, because we are assuming ceteris paribus condition. Then in this case you have to use partial differentiation, because partial differentiation is total differentiation while keeping other factors constant. So when you are doing partial differentiation of log pi with a log p, then W and Z, W1, W2, so price of factor 1, factor 2, and Z, quantity of Z, all these are assumed to be constant. So when you differentiate, it is very easy to understand. The partial derivative just comes out to be beta 1, but you know that if you differentiate log, so you can find uh, partial differentiation of further log pi as deba pi by deba pi and deba p by deba p by p. So here we have elaborated it further. So now we have deba pi by deba p times p by pi equal to beta 1. So further simplification leads to deba pi by deba p, which was our interest to get. So which is equal to beta 1 times pi by p. And remember, as per the statement of the Hoteling's lemma and the property that we discussed, the partial derivative of profit function with respect to price of output should give you the quantity Q. So we have written equal to Q also here. So same thing which was stated earlier is written here. Now if you work upon these, so it is applying log on both sides. So log Q equal to log beta 1 plus log pi minus log p. Now you have to substitute the expression for pi here. So we have substituted log pi sub expression, which was the Cobb-Douglas profit function. Then collecting terms, we get these. And now we have obtained a supply function which is also Cobb-Douglas specification and is a function of price of output, price of input and fixed factor. So we said while discussing profit function that there is one-to-one correspondence between profit function and the output supply function or the production function. So we started with a Cobb-Douglas profit function, and the output supply function is also of Cobb-Douglas specification. So there is a one-to-one correspondence between the two. Supply in very short run period. So we discussed the short run period where both fixed and variable inputs were there. But in very short run period, the production capacity is fixed, the plant size is fixed, all inputs are fixed in nature. You don't have variable input here. So quantity of input cannot be adjusted to give more production if the demand is more or prices are increasing. No. So no extra production is possible by applying extra input. The produce once produced has to be sold in very short period of time. So in such a scenario, the supply is fixed. So the marginal cost of production is fixed. The producer can maximize the profit by selling produce at price equal to or greater than the marginal cost. The supply curve is insensitive to price changes, so it's just a vertical line. It's just a vertical line. So if you have price on y-axis and quantity supplied on x-axis, so the supply curve is just a vertical line. Its distance from price axis is equal to the sum of output of the firm. So whatever firm is trying to supply the output, so that is the distance between the y-axis and the supply curve. Supply in long run period. So in long run, there are no fixed input. So in short run, we had both variable as well as fixed input. The average variable cost is same as average cost of production because there is no fixed cost. So the average variable cost is same as average cost. The supply curve is portion of long run marginal cost of production which is above the long run average cost of production. So earlier we were saying that the marginal cost portion above minimum of average variable cost. Now minimum average variable cost is not relevant because there is no uh, nothing called fixed factors. So the supply curve starts from minimum of average cost. The long run supply function is having greater price elasticity than the short run supply function. Obviously, it is that in short run there were some fixed factors so which were constraining the size of plant. So in long run, the firm is free to increase its size of plant, so it can augment the supply, and technology upgradation is possible in the long run which was not possible in the short run. So there are many possibilities in the long run. So supply will be more elastic in the long run. So supply curve, because it is more elastic, so will be flatter in the long run compared to the short run. Thank you so much for listening to me. Please subscribe to my channel. Thank you so much.